This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Randy Field, the Executive Director of MIT's new Future Energy Systems Center, to discuss this new initiative and its impact on Maritime Field. Randy, to start, can you give a by-the-numbers look at the Future Energy Systems Center today using the metrics of your choice?
Sure, yes, absolutely. The Future Energy Systems Center, which began a few months ago, has 26 member companies in it. We have more than 20 different projects in our research portfolio today across 6 focus areas, including, of course, transportation. I should also say that this center lives within the MIT Energy Initiative, which has been in existence since 2007 when Ernie Moniz and Bob Armstrong started it up, and we've deployed more than $850 million in funding to date.
With the energy transition, there are many new and emerging initiatives to help facilitate this energy transition. How is the Future Energy Systems Center different?
Well, our approach to the energy transition is to take a very holistic look at the entire energy system and consider all the sector coupling issues, which are massive, actually, because decarbonizing the world is a very complex beast. It's very heterogeneous. And so we take a holistic approach, and we look at not just, we think of MIT as technology, and it is, but we look at the technology, we look at the economics, and we look at the policy issues. We also engage closely with industry, because industry are the ones who are going to deploy the technology, and they're vital to both understanding the scope of the problems and figuring out how to make it happen. And we take a very multidisciplinary approach at MIT, considering the engineering, the economics, as well as social behavior as well. And I also want to commend, we talk about different groups working on this. I also want to commend our friends over at the Maersk McKinney Mauller Center for Zero Carbon Shipping. We have had great discussions with them, and we're looking forward to collaborating with them on decarbonization of shipping.
What do you see as some of the unique challenges facing energy transition in the maritime sector?
Well, as you know, shipping is a very tough sector to decarbonize. There is just currently no fuel options out there that address all the requirements for international shipping. Those requirements include, of course, high energy density, the potential for that fuel to be zero carbon in the future, the ability to scale those fuels as needed for the shipping sector, and very importantly, low cost, as well as health and safety. The industry is facing a very tough issue of lock-in right now, which is, of course, any new ships that are ordered today will still be in service in the year 2050 when we're trying to get to net zero. And, so it's a very difficult choice for shipping companies to make on what their ships should be that they order today, and what will be the supply of fuels, zero carbon fuels in the year 2050. And so it's the lock-in challenge is very severe.
As you pointed out, obviously, MIT and technology go hand in hand. So if I can just stick on the technology for a moment, when we look at the breadth of emerging technologies, what do you see as having the best prospects to move us further, fastest towards this decarbonization?
Well, it's a challenging issue. Every fuel option out there has its challenges as well as uncertainties. We can discuss the challenges on scale, cost, carbon intensity, energy density, powertrain maturity, emissions, and by emissions, I mean not only carbon, but all the other emissions that we have to consider as well, and the safety, and we can discuss that as time permits here today. But the options, there are many options on the table, and there's no surprise here. Of course, you've got various biofuel options, synthetic fuel options, methanol by various pathways, hydrogen, ammonia, as well as renewable LNG. And some of these can serve as drop-in fuels, which makes the flexibility issue much more straightforward. But others require entirely different powertrains, which creates more challenges for how do you buy a ship today and modify it in the future and so forth. So a lot of issues there. So basically, there is no silver bullet. And we have to do the hard work of working through these issues at the technology front as well as at the overall system level of how does this interplay with all the other system, energy system sectors, including, say, power, power to fuels, and all that.
Okay. Well, it's interesting because a lot of our discussion obviously focuses on the future technologies, alternative fuels, and the like. When you look at existing technologies today, and I'll just give it as an example, we talk to, the coatings manufacturers and the ability to keep a hull clean, to move that ship through the water more efficiently, saving on the fuel burn and saving obviously on the emissions as well. When you look at existing technologies, do you see anything that would have an immediate impact now?
Well, anything that delivers efficiency with existing ships is highly valuable, whether it be friction reduction by the surface coatings and other types of things, as well as design of the hulls. Those are all valuable. There's, of course, optimization of the logistics and how we decide how we make decisions on the best way to move material from one location to another, as well as the question of how do you optimize against weather patterns and slow steaming and so forth. So there's a lot of opportunity there that should be done and can be deliver more profits for the shipping companies. But none of those things gets you to net zero. That's the issue, is that efficiency is wonderful, it's necessary, it's profitable, but it doesn't get you to net zero. So these are things that should be being done, but they're not the silver bullet that we're looking for.
Randy, as you discussed at the outset, this is not just a technical issue. It's not just an economic issue. It's not just a societal and a political issue. It's a big issue that has many tendrils. While I'm sure there are many, what do you consider to be the one or two biggest challenges today to move towards this decarbonization?
Yeah. Okay. Yeah, Greg, the technical issues, the cost issues, those are actually manageable issues. The biggest challenge that I see here is the geopolitics and the policy uncertainty. If the world could implement policies that are firm, that are long-term, and eliminate leakage, then the shipping industry and the shipbuilders and the fuel providers would then have a clear and compelling price signal on what they need to do, and the innovators and investors would be able to contribute to bringing down the costs. Sadly, we are very far from having such policies. I mean, we've been making great progress on climate policy, but we're far, far short of where we need to be. Now, I just mentioned leakage, and just to be clear, just in case the audience is not aware of what I'm meaning there, is by leakage, what we recognize is that international shipping involves ships from many different countries, some that abide by IMO and others do not. And if you have policies that make certain shipping companies follow the rules, and then other companies, ships don't follow the rules, then that results in leakage of various types, meaning others will produce the CO2 emissions that could actually tremendously undo all the good that's being done by the shipping companies that follow the rules.
Are there any initial projects within the center with an impact on maritime or offshore energy that you can discuss?
Yeah, no, that certainly. We have quite a few projects underway, as I mentioned, more than 20, but all of the low carbon fuel pathways for shipping involve hydrogen at some stage in their production. Even if you're not going to put hydrogen on ships, of course, hydrogen may be involved in producing that synthetic fuel or that methanol or any of the other fuels. And we have a number of projects underway that are tackling the question of hydrogen. And one of the ones that I want to mention is that we're starting a project now looking at pathways towards gigaton scale low carbon hydrogen production. We're basically examining the different pathways for making hydrogen, And we have another project starting in February that is looking at MIT's project is looking at large-scale use of ammonia as a fuel for maritime shipping. I'm involved with that project, and it starts next month.
Well, Randy, I truly appreciate your time, and I certainly look forward to talking with you and your team again as this progresses.
Thank you very much, Greg. It was my pleasure to be with you today.